This conference will now be recorded.
So, very good evening, students. Today we are back with a revision of JEE advanced papers on magnetism. So, as you know, we are solving numerical problems from previous year's JEE paper. So, this particular question is from JEE advanced paper 2014, paper A, paper 1. Okay, so today we are concentrating discussions on the galvanometer part. I have picked a few questions on galvanometer. So today I'll just discuss in such a way that concept related to galvanometer becomes much more clearer. Basically, few terms like full scale deflection, voltage range, current range, and also how to convert a galvanometer into voltmeter and a galvanometer into ammeter. And questions are related to that. Okay, so let us start today's first question on galvanometer. So this question says a galvanometer gives full scale deflection with 0.006 ampere current. By connecting it to a 4990 ohm resistance, it can be converted into a voltmeter of range 0 to 30 volt. If connected to a 2n by 249 resistance, it becomes an ammeter of range 0 to 1.5 ampere. The value of n, you have to actually find out what is the value of n. Okay, this is a question where you have to find out answer in integers, a number. Okay, so look here, this problem deals with the knowledge of galvanometer, right, and conversion of galvanometer into a voltmeter or an ammeter. As you see, both sections are there. A galvanometer can be converted into a voltmeter by connecting this much resistance, that is 4990 ohm resistance, and it can be converted into an ammeter when you connect 2n by 249 ohm resistance. Okay, and the range of the ammeter is also given, that is 0 to 1.5 ampere. So first of all, to solve any question related to galvanometer, what are the terms we should know? Look, I am just drawing a schematic diagram of a galvanometer, like circuit diagram of a galvanometer, not schematic, circuit diagram. So circuit diagram generally we draw like this. This is G and this is RG. RG in the sense the galvanometer internal resistance or the galvanometer resistance associated with the galvanometer itself, and this may not be very large value. Okay, so this is circuit symbol of galvanometer. Now if you want to convert this into a voltmeter or an ammeter, you need to know two things. What are the things you need to know? You need to know what is the allowed current through the galvanometer, that is IG say. So what is the allowed current through the galvanometer? Okay, that is actually called the maximum limit of the galvanometer, maximum limit of the current of the galvanometer. Okay, so that same thing has been told in another language. The galvanometer gives full scale deflection. Okay, galvanometer gives a full scale deflection. So what I am going to discuss is the term full scale deflection. See here, neither of this RG and IG is given. Sorry, IG may be given, IG, but that is not told in that way, straightforward way, that the galvanometer current is IG, and that is not told in the question. Okay, and this RG is not at all given. So these two parameters we have to calculate first of all, if you want to convert a galvanometer into a voltmeter or an ammeter. So this is the first thing you should do. Look here, there are few terms like the range, voltage range, then ammeter range, ammeter current range, and the full scale deflection. What is full scale deflection? What is full scale deflection? See, when you go to the lab, you'll see a galvanometer is like this. Okay, so you will see there will be a pointer. Okay, and there will be graduations or the scale divisions of current. This will be 0 or neutral, and this way there will be some divisions of current. This way also there will be divisions of current, and throughout the divisions are same. If it deflects towards this side, then the current is positive, and if the deflection is in this direction, then the current will be negative. Okay, now look, what is full scale deflection? Actually, suppose there are 50 divisions, okay, and some particular current will be there, which is the current, maximum limit of the current, for which the galvanometer, this pointer, will show the maximum deflection or full scale deflection. That means all 40 divisions will show. Okay, that means suppose this is 40 divisions here, somewhere here, so it will show the maximum deflection. Okay, so that particular current, so the current corresponding to full scale deflection, that means if the galvanometer has 50 divisions, there will be a particular current for which this pointer will show the deflection of up to 50 divisions. Okay, or it is called full scale deflection. Okay, or galvanometer exhibits the maximum deflection, that is actually called full scale deflection, and the current for which the galvanometer exhibits the full scale deflection, that current is called, that corresponding current is called galvanometer current. That corresponding current is actually galvanometer current. Okay, so that is IG. Here look, a galvanometer gives full scale deflection with 0.006 ampere current. That means the galvanometer current is this much, 0.006 ampere. This is the galvanometer current. Okay, and beyond this current, actually galvanometer will get damaged. Okay, beyond this IG, that means beyond this full scale deflection current, the galvanometer will not work properly, that will get damaged. So this is actually IG, or full scale deflection. Meaning of the full scale deflection is the corresponding the current corresponding to the full scale deflection is the maximum allowed current through the galvanometer. Beyond that particular current, the galvanometer will get damaged. Okay, so we have got IG, right? We have got IG from the question. It is given, IG is given as 0.006 ampere. Okay, so this is done. Now we have to see what is RG, whether there is some clue to get RG. Let us see. By connecting it to a 4990 ohm resistance, it can be converted into a voltmeter of range 0 to 30 volt. Okay, look here, we need to know how to convert a galvanometer into a voltmeter. This is what we need to know first, and from there actually you will be able to find out this RG. Okay, what is that RG? We will be able to find out. RG means the galvanometer resistance or internal resistance of the galvanometer. See, a galvanometer can be converted into a voltmeter if we connect a very high resistance in series, RS, a very high resistance, that means RS is much greater than RG. Okay, we have to connect galvanometer in series with a very high resistance, external resistance, then it can become, or it will be converted into a voltmeter. Okay, now see in the question, so it can act as voltmeter now. Okay, in this situation. Okay, now we'll go to the question itself. So it can be converted into galvanometer. See, the question is given here that in the question it is given that this RS, if we connect this resistance 4990 ohm with the galvanometer, then this galvanometer gets converted into voltmeter of range 0 to 30 volt. Okay, so this is the thing. That means 0 volt here, and at the end it will be 30 volt, right? So this is the case. Now see, RS is obtained, RS is known. Then can you find out what is RG? Answer is yes, we can find out. Let us see what we can do for this. So I'll just do this here itself, or maybe in the next page. So what are the options given? Sorry, what are the informations given? Information of this is given. RS is given. Okay, RG we need to find out, and IG is given. IG is the current which, because the resistance, this external resistance RS is connected in series with the galvanometer, so the current will be flowing. So this voltage is now 30 volt. Okay, Okay, voltage across both this and this. Then what I can write from here, the figure from the figure. So Ig into Rg plus Rs. Okay, so this is equal to 30 volt, right? So this is equal to 30 volt. Now Ig is known, Rs is known, Rg is easy to find out now. Rg is 30 divided by Ig minus Rs. Now look, this 30 volt divided by Ig is 0.006 ampere. This is volt. So this unit will be again a of resistance, and this is now 4990. So ultimately it will be ohm in ohm. So look this here, if this will be 10 to the power minus plus 3 divided by, so plus 4, right? 10 to the power 4, and here it is 6. Better to keep this as 10 to the power 3 and this 30, so it will be 5. So this part will be actually 5000 now. Okay, 5000 minus 4990. So look then, what is the value of Rg? What is the value of Rg? The value of Rg is becoming 10 ohm. See, I told that galvanometer resistance is much lesser than, or this series resistance is much greater than Rg. See, Rg is 10 ohm and this series resistance is 4990 ohm. Okay, so which is much greater than 10 ohm, right? So guys, what we have got, as I told, we need to, for a galvanometer, and if you want to convert a galvanometer into voltmeter, what you need to know, first of all, you need to know Rg and Ig. Okay, Ig and Rg, these you should know. So I have obtained Ig and Rg both. Look, I'll write it here. So I have obtained the parameters for the galvanometer. Rg is 10 ohm and Ig is 0. Okay, let me write in power, 6 into 10 to the power minus 3 ampere. Okay, 6 milliampere or 10 to the power minus 3 ampere. All right, these are obtained. Now look the last part of the question. If connected to if this galvanometer is connected to a resistance given by 249 ohm resistance, it becomes an ammeter of range 0 to 1.5 ampere. Okay, the value of N you need to find out. That means last part is related to conversion of a galvanometer into an ammeter. First of all, let us look how to convert a voltmeter into an ammeter. Okay, an ammeter. And what is the meaning of ammeter range? Okay, look this. All right, see how to convert a galvanometer into an ammeter. See, for this, you know, since ammeter is connected in series in a circuit, we should actually shunt the galvanometer. We should shunt the galvanometer. So galvanometer current will be Ig, and the main current of the circuit, say I, will be divided into two parts. One will be through, this is S, say, one will be Is, which is very less, very less. Okay, very less compared to this I. Since ammeter is always connected in series, So galvanometer has to be shunted with a very small resistance such that the maximum, I'm sorry, this is wrong. This is actually is much greater than Ig. That means maximum current will be passing through this low resistance such that the current in the circuit will not be reduced. Okay, and all the component, this is a measuring device, right? So measuring device should not withdraw current such that the appliances work with their full efficiency, right? So this is why we have to connect a very small resistance in parallel, like parallel to the galvanometer, such that the whole current passes through the small resistance without any hindrance. But for working, galvanometer needs certain amount of current Ig that is very less. As you see, 6 milliampere, sometime it can be microampere also. Okay, that much current galvanometer will draw. We don't mind with that. Okay, so if this is the circuit diagram for a galvanometer to convert into an ammeter, then see from here what we can write from circuit diagram. Look, I can write, see, since this S is the resistance in shunt resistance, so this S and voltage, so voltage across both the galvanometer and this shunt will be the same. So I can write Ig into Rg, which is the voltage drop across the galvanometer, that will be exactly equal to the voltage drop across the shunt. And shunt resistance I have taken as S. So S in Is into S. Look here, what is this range? Ammeter range. Ammeter range. So ammeter can measure maximum current. How much? 1.5 ampere. So that is actually the main current. 1.5 ampere is I, which is getting divided into two parts, Ig and Is. So I can just write this Is as I minus Ig. Since Ig is known, okay, we can write Is as Ig. So let me write it here. Ig, Rg, both are known. Is is not known. I am writing it in terms of known quantity because I is the total current which is divided into both Ig and Ic. Sorry, Is. So Is will be I minus Ig into S. S is already given. This much resistance has to be connected in parallel, right? So this resistance is already given to N by 249, and here you have to find out what is the value of N. Now look what we get here. So Is into S is equal to Ig into Rg, which we have written as I minus Ig into S and Ig Rg. Okay, now what is S? S is already given, you have to find out N. So let me see, we just compare with our value and the given value. So S into I minus Ig. So Ig is given as 6 milliampere, 10 to the power minus 3. Rg is given 10 ohm, and S is given as 2N by, sorry, this S I am calculating actually. Let us not write it here. So I is given 1.5 ampere, Ig is given 6 milliampere or 0.006 ampere. Okay, so this will be in ohm. Look, this value, so 1.5, 0.00649 This is 1494, okay, somewhat like that. And this is 6 into 10 to the power minus 2 divided by 1.494. I can just approximate it to 1. No, it's okay. So this is okay. Let me just do one thing. I will 10 to the power minus 2 and here 1.4. Let me just make it to round figure and write 10 to the power minus 3. So 10 to the power minus 3, 10 to the power minus 2, here 110 will be multiplied. Okay. Now look, if I just do this division with 6, I hope it may go. So 6 to is 12 to 9, 6 4 6 4 25 4. Okay, so 25 6 for 24, sorry, 24. So this is 5 5, this, so this is 249. So this factor is 249. Okay, 249. I hope I have done some mistake somewhere. 1 2 is missing. Let me just check. Okay, 2n, it is 2n, right? All right, so it is all right. So we have got, finally what we have got is s we have got, let me write, we have got s, or s is equal to 10 by 249. See what was given, 2n by 249. So 2n is equal to, so we have got actually s as 2 into 5 by 249, and it was given as how much, 2n by 249. Okay, so 249 goes off, this goes off, so this implies that n has a value of 5. Okay, so this is a lengthy question, in the sense we need to know all the terms, so that's why I have discussed, because I am going to discuss 2 more problems on this galvanometer, so that you are not getting confused with the terms I have already discussed. So the value of n is 5. Okay, all right. So this was a long discussion. Let us go to the next problem and try to solve it. Uh, since we have at least some idea now about the galvanometer, now we'll solve a nice problem that is purely a numerical one. Okay, let us go ahead. Okay, so two identical coil galvanometers have 10 ohm resistance and full scale deflection 2 microampere. So galvanometer has both two identical galvanometers. There are two galvanometers. Excuse me. So two galvanometers. So this is RG, this is G, okay. And say another galvanometer. So suppose this is galvanometer 1 and another galvanometer G. This is RJG again. So let us say this is 2 and this is 1. RG1, R1G, R2G, and this is galvanometer 2. Actually, they are identical to each other, and see the two identical moving coil galvanometers have 10 ohm resistance and full scale deflection at 2 microampere current. That means Rg for both of them, internal resistance of the galvanometers are 10 ohm, and full scale deflection for both is 2 microampere. That means for both of them the galvanometer current or maximum allowed current through the galvanometer is 2 microampere. Okay, so these are the two points we have understood from the first line itself. Now one of them is converted into a galvanometer of 100 millivolt full scale reading. Okay, a voltmeter of 100 millivolt full scale reading, and the other into an ammeter of 1 milliampere full scale current appropriate using appropriate resistor. See, now here also the question is related to conversion of a galvanometer into a voltmeter and an ammeter. Okay, so first galvanometer, both are identical galvanometer. So one among them is converted into a voltmeter of resistance. Of maximum range or full scale deflection. Full scale voltmeter has full scale or maximum range. Maximum range is 100 millivolt. Okay, and the other one is converted into an ammeter of range, maximum range 1 milliampere. Okay, used to measure the voltage and current in Ohm's law experiment with external resistance. How much? 1000 ohm resistor using an ideal cell. Which of the following statement is or are correct? That means there may be multiple answers correct. So see, I have two identical galvanometers which I have converted into, like one among them is converted into a voltmeter and the other one has been converted into an ammeter, and both of them are used, like voltmeter and ammeters are used in Ohm's law experiment. Okay, where we are using 1000 ohm resistor by using, and also we are using an ideal cell. So which of the following options are correct? The first option is the measured value of resistance will be between this 978 ohm and 982 ohm. Okay, we'll see these options. The resistance of the voltmeter will be 100 kilo ohm. Okay, then the option C says if the ideal cell is replaced by a cell having internal resistance 5 ohm, then the measured value of R will be more than 1000 ohm. Okay, and the resistance for last option is the resistance of the ammeter will be 0.02 ohm, round off up to second decimal. We'll see which option or which are the correct option here. Okay, so okay, let us work with this information first. The galvanometer has been converted into a voltmeter. Okay, so for that case, how much? Okay, so let us see. So we have been given galvanometer Rg, and this is voltmeter, we know. Okay, so it has been converted into a voltmeter, okay, of voltage 100 millivolt. So Ig is given, Rg is given, Rg is 10 ohm, it is given, and Ig is given as 2 microampere, and this is converted into a voltmeter. So what we should do, we should actually connect a very high resistance Rs to convert into a voltmeter, and voltmeter range is given actually. What is the voltmeter range? this voltmeter range was given as 100 or 1000. It is given 100 millivolt. Okay, 100 millivolt means this much into 10 to the power minus 3 volt. Okay, this is the total voltage. So look what we can get from here. We can get RS from here. Okay, if we want, we will get RS from here. Okay, so let us find out. It is like what is the so resistance of the voltmeter will be here. The question one option was there. The resistance of the voltmeter will be 100 kilo ohm. We have to find out what is the resistance of the voltmeter. Then this is the voltmeter, so it has two resistances. One is RG, another one is RS. So RS is not given, right? So we have to find out what is RS. See, from this circuit diagram we can write, as you know, we can write IG into RG plus RS, which is the maximum range of the voltage of the voltmeter. Okay, so this is 10 to the power minus 1 volt. Okay, it is from here. Okay, Ig is given, Rg is given, so Rs will be this 10 to the power minus 1 volt divided by Ig minus Rg. Okay, now look, this 10 to the power minus 1, 10 to the power minus 1, this I can write 1 over 10, and Ig is given as 2 microampere. 2 microampere here in the down, so 2 microampere, micrometer 10 to the power minus 6, so I'll just keep it here 10 to the power minus 10 to the power 6. Okay, this is ampere now, and this is volt per ampere, so it will be in resistance unit, and Rg is given as 10 ohm. Okay, 10 ohm. Let us see what happens now. So you look here, this is 20, so I can just make here 100, and this is 10 to the power 4, and this is 20, that means it will be 5 into 10 to the power 4, right? 5 into 10 to the power 4, that means 50,000 minus 10 ohm, so this will be how much? So approximately, so it is actually 4,999 ohm. Okay, so we have got RS. So what is the resistance of the voltmeter? Resistance of the voltmeter that is Rg plus Rs. So this is 4990 plus 10 ohm. So this is 5,000 ohm, right? 5,000 ohm means, sorry, 50,000. I've written 5,000, right? There will be another 9, so 49,000. It will be one more 90. So 49990. So this is 50. This is 50,000. Okay, 50,000. That means it is 50 kilo ohm. So the question in the option, what was that? The resistance of the voltmeter is 100 kilo ohm, which is not true. It is actually 50 kilo ohm. Okay, so therefore this option is not correct. Now we'll see with another information. These are then used. Okay, so let us see when we convert this into a galvanometer. Sorry, galvanometer into an ammeter. And ammeter related questions will be must be there. See, resistance of the ammeter will be. We have to find out what is the resistance of the ammeter. Let us just, okay, let me just draw the circuit diagram for conversion of a galvanometer into a voltmeter, sorry, ammeter. See, this is the S, you know that we have already discussed. We have to connect a very less resistance or very small resistance in parallel with the galvanometer, so which is called shunt. So we have to shunt the galvanometer. Okay, Rg is 10 ohm. Ig, we know Ig is 2 microampere. Okay, now we have to find out what is S, and then ammeter resistance of the ammeter will be Rg parallel S. So this parallel combination, resistance of this parallel combination will be the resistance of the ammeter, that we can find out once you get S. So how do you get S? See, the range of the milliampere, sorry, range of the ammeter is given 1 milliampere. So which is actually the I, as you know, 1 milliampere, this is 10 to the power minus 3 ampere. Okay, and that gets divided into two parts, Is and Ig, right? So from here we can directly write I minus Ig into S is equal to Ig into Rg, right? So from here Ig into Rg divided by I minus Ig in okay, so from here we will get the resistance. See here Rg, this is Ig is 2 into 10 to the power minus 6 ampere. Rg is given 10 ohm divided by I is given 10 to the power minus 3 minus 10 into 2 into 10 to the power minus 6. Okay, so these are given. So if you calculate the resistance from here, if you just do the calculations with patience, I'm not doing now, so it will give you actually how much. It will give you 0.02 ohm. So this is much lesser than even the Rg. Okay, so shunt resistance will be much lesser than even Rg, or resistance is internal resistance of the galvanometer. Okay, so we have got the galvanometer resistance. So we know the galvanometer resistance from the question. We have obtained the shunt resistance for converting this galvanometer into an ammeter. So then, so what is the resistance of the ammeter? So Rg is 10 ohm and S is 0.02 ohm, which I can write 2 into 10 to the power minus 2 ohm. Okay, if required. So now galvanometer ammeter resistance of the ammeter Ra I am writing. So it is parallel combination, right? So it will be multiplication Rg into S divided by Rg plus S, sorry, plus S, Rg plus S. Okay, so Rg, what is Rg? Rg is 10 ohm, right? And what is S? S is 0.02 ohm divided by Rg 10 plus 0.02 ohm. Okay, so look here, it is actually 0.2 ohm divided by 10.02. That means we just approximately take, so this will be nearly equal to 0.02 only. Okay, or much less, even lesser than that. The answer was that the resistance of the ammeter will be 0.02 round, like round of second decimal up to second decimal. If we divide it, it will be nearly 0.02. So this is actually a correct option here. Okay, this is the correct option. So we have checked two options. Now we have to see other two options. First option is the measured value of R will be, the measured value of R will be, the measured value of R will be how much? Okay, now see this galvanometer. Let us go to this page. Let's see this galvanometer and voltmeter. Sorry, this voltmeter and ammeter, which we have obtained from conversion. are used in Ohm's law. Ohm's law circuit diagram will be, this is the R resistance which is used in the Ohm's law experiment. And see, always voltmeter will be connected in parallel to this resistance, and then ammeter will be connected in series. Okay, ammeter connected in series, there will be cell here. Okay, now see, current will flow like this, as you know, and this current will be actually divided into two like this. And galvanometer has a very large internal resistance, so we'll see that the whole current is passing through the circuit. Okay, there is no loss of current, so that is what we will take, right? All right, so this is the unknown resistance. Suppose X, we have to find out unknown resistance, we have to find out. Okay, voltmeter is given, and see, E is the EMF of the battery, suppose. Okay, EMF of the battery. Look, then what we do generally in this experiment, so this is some fixed voltage, let us say some 10 volt. Okay, this resistance has some fixed value, right? So there will be fixed current flowing through the circuit. That means if you somehow change the current through the, so this is current, this is voltage. Okay, and voltage across this unknown resistance, and the resistance will be V by I. Okay, this is the table we generally use. We use for some current, some small current will use with regular interval maybe, and then we'll try to draw the graph, and you know the graph will be always going through the IV characteristics or VI characteristics, whatever you say. The current will be like this. So the graph will be like this, and then from the slope you will be able to find out the resistance. Okay, all right, so this is the way. Now what I'm having informations in this problem is that voltmeter resistance and galvanometer resistance are given. Sorry, voltmeter and ammeter resistance are obtained. This is another resistance R. Okay, let me just keep this as R itself. So these are three resistances are there, right? So three resistances are there, and see, if I draw a equivalent diagram of three resistance, now this is actually the circuit diagram. This is the circuit diagram. So this is RA, this is R, this is RB, and see, here it is the cell with fixed voltage. Okay, fixed EMF, that is E. Suppose current is flowing like this, right? So we have to find out what is capital R. Okay, so here we can find out we can actually write down okay, we can actually find out what is the current through the circuit. First of all, what is the circuit current? That is EMF by equivalent resistance, right? R equivalent. Okay, so what is R equivalent here? R equivalent, look here, R equivalent is, see, RA in series and parallel circuit is R into RV divided by R plus RV. So these are This is actually equivalent resistance. Now if we write it here, this RA plus R into RV by R plus RV. So this is what we get. Now using KVL in this circuit, using KVL, okay, using KVL for this loop, what we can write, if I know the equivalent resistance, okay, so what we can do, okay, let me go to the next page. So E minus I into RA and if the unknown resistance, so since it is actually, see, RV, we have already found out what was RV. RV was 50 kilo ohm, right? And R, this is taken as how much? It is 1 kilo ohm. That means, from here we can actually just neglect this part alone, okay? We can neglect this part. We can just write this, like, see, R and R, this parallel combination will be uh, parallel combination. We can actually see the current actually through this voltmeter will be, current passing through voltmeter will be very, very less. So that's why what we'll be able to write is E EMF minus I into RA minus the unknown resistance is equal to 0. Okay, all right. So from here, so we have already found out current. Okay, that current will be using now. So our motivation is to find out what is R. Okay, what is this R? That is the motivation. Okay, so if we want to find out what is R, then we have to, okay, so let us just go ahead. So this R has to be found out from here. I into RA. So we know what is I. I is this by RV, R divided by R plus RV. This was the case. Okay. All right. So along with that, RA is multiplied. Now, if you solve it, look, this will be, see, this, if we multiply this, look, we'll just keep it here. So RVR into E minus R plus RV into E divided by R into RV into RA. So like that, if you just try to do the simplification, if you try to do the simplification, okay, there will be one RA here. So I'm sorry, it is, okay, this is, I'm just writing the value of I. We have already found out what is I. that I'll just write it here and try to solve it. Obviously this is a lengthy question. See, current was E by this. So that is what I'm writing here now. E by RA plus RVR divided by R plus RV whole into RA. Okay, this is into RA. Now see, if we try to solve it, we'll get this R as okay. I should have written this as X actually, not R. X. Because I am just taking this current, which sorry, this to be X now, which is measured through the experiment. So that is what I'm doing now. Okay, now if we divide with I, okay, so divide with I, then better I'll just do it here. Divide with R, sorry, I, all the sides. So this will be I, this will be this by I, and this will be RA alone. And as I said, you can put the value of this is I by RA plus RRV divided by R plus RV, okay, minus RA. Like this, if you do it, you'll come to a point where you get R into RV divided by R plus RV. Okay, so this R is given as 100, sorry, 1000 ohm. RV, voltmeter resistance, is given as 50,000 ohm divided by this is again 50,000 plus 1000, right? So this is 5 into 10 to the power how much? 4 and 3, so 7, 10 to the power 7 divided by 51000, so 30 goes, so this will be 4, so 5 by 51 into 10 to the power 4, so you can just make it 500 and 10 to the power 2 divided by 51. Okay, so if you now divide this 500 with this, then you have 9, and this is 1, goes to, so there are 2 more, okay, zeros. I'm just writing 64410 comes, so again it will be 8, and this goes 2 0, so it is actually 984. Okay, 51, right? So 984 980.4, it will come as 980.4. okay, so 980.4 is the resistance we will be able to measure with the Ohm's law. Okay, So the question was whether this value is this, measured value is this. So we have obtained that we'll be found out, or like we'll find out this mass resistance from Ohm's law, which is actually coming under this range. Okay, coming under this range. So this is also correct. And the third option C is saying that if uh, the ideal cell is replaced by a cell which has internal resistance 5 ohm, so in that case how it varies? Actually in that case, if the internal resistance is there, in that case the measured value of R will be more than 1000 ohm. Actually we have already seen when uh, okay, let me go to the next page. So here when I can be written as E by R when there is no internal resistance. But if there is internal resistance, see, then I can be written when the internal resistance is there, then okay, so it will be actually, it will be I divided by epsilon by F this. So this will be the case. So since it is actually, see, in the previous case what was that? In the previous case we had current. Obviously we need to know the circuit. So circuit, this is R, unknown resistance, this is ammeter, and this is voltmeter over here, V, this is A, and this is EMF E. Now there is a small resistance over here. So this resistance actually will be in series, RA plus small r, and this will be in parallel again. So R into RV by R plus RV. So this is there. So along with this term will come. Okay. Actually, in any case, see, uh, if the internal resistance is even added, internal resistance added, actually see, there will be no term. Okay, so expression for the measured resistance does not contain E alone. Okay, see, we have calculated r prime as rv divided by r plus rv. I hope you remember this. So in this, actually, see, there is neither EMF nor internal resistance is involved. Okay, neither EMF nor internal resistance is involved. Okay, so in the measurement of resistance, so this is the point here. In the measurement, obviously in the current measurement is fine, but when we are doing resistance measurement, so in the measurement of resistance because these are the parameters we'll be using. Okay, sorry. In the measurement of resistance, neither EMF nor the internal resistance is involved. Resistance is involved. So whatever may be the internal resistance, doesn't matter. The value of the resistance will be the same. That is, so R prime will be 980.4, which we have already calculated and shown you. 980.4 ohm. So this much only. It is not like if the internal resistance is becoming like there is like if the cell is not ideal cell, that means there will be some internal resistance. In that case, also the expression for the measurement of resistance from Ohm's law will not change. Okay, that will not change. So that's why it is true that internal resistance or the replacement of the cell, ideal cell, by a cell which has some internal resistance will not affect in the measurement of resistance in the Ohm's law. Okay, so this is all for today. These were actually really lengthy questions, and since I am discussing in detail, it become too lengthy. But anyway, in the next class, we'll see one or two more years galvanometer. So this question was actually from 2019, I hope. Yes, 2019 paper 1. This was JEE Advanced 2019 paper 1. Okay. All right. So we'll stop it here for today. Next day we'll take up few more problems on galvanometer and then we'll proceed to some other topic. Okay. So thank you for your presence. Bye for today.